Okay, we are back at it today with 5 more examples of algebraic manipulations solving for one variable using an equation with more than one variable. We'll start with 2 problems similar to the ones that we covered in the last video. In this case, we have x and y showing up in the equation, and we are asked to solve for x. So once again, we want to move any term with an x to one side and everything else to the other. It's okay to go to the left, it's okay to go to the right, it's completely up to you. I will go left. And so my first step, I have 9xy minus 7x is equal to 2y plus 4. So I've added 4 to both sides, I've subtracted 7x from both sides. I'll now factor out an x, since that's what I'm solving for. X times the quantity 9y minus 7 is equal to 2y plus 4. And then last but not least, I'll divide by this quantity, 9y minus 7, divide by that quantity, 9y minus 7. Of course, x times 9y minus 7 divided by the quantity 9y minus 7 is just x. That simplifies. And over here we have x is equal to the quantity 2y plus 4 over the quantity 9y minus 7. Again, you could, if you wanted to, you could think of these as being wrapped in a pair of parentheses. We cannot reduce that to 1. Cannot get rid of those y's. We're finished. If you had gone the other direction, in terms of at the start, moved the 7x to the left and the 9xy to the right, then your solution for x would have been negative 2y minus 4, that's a 4, over negative 9y plus 7. And remember from yesterday's video, those are absolutely equal to each other. Next example, very similar. I'd encourage you to pause now and try it on your own and then watch the solution. Our first step, in this case we're solving for y, would be to move any term with the y to one side and everything else to the other. I'll move this to the right and I'll move this to the left, and that would give us 3 minus 5x is equal to positive 6xy minus 2y. Since I'm solving for y, I'll factor out a y, and I'm left with y times the quantity 6x minus 2 is equal to 3 minus 5x. Last but not least, divide by the quantity 6x minus 2, and I have y is equal to 3 minus 5x over the quantity 6x minus 2. One more time, if you had reversed this and moved the, let's see, 2y to the left and the 3 to the right, then you would have had all signs opposite. In other words, positive 5x minus 3 over 2 minus 6x. And as I've mentioned many times before, resist the temptation. You cannot slash those x's because we are adding and subtracting here and not multiplying. Next example, again, I'll encourage you to pause and try it on your own first. Okay, in this case we have this a off to the side, and in an example in yesterday's video we took the denominator and we multiplied both sides of the equation by that denominator in order to get rid of that denominator in the expression. In this case we need to take an additional step first, and that step is to subtract a from both sides. And so that would give us a minus cx over b plus dx is equal to the opposite of a. Keep in mind that we're being asked to solve for x. I'm going to change colors here. At this point we can multiply through by that denominator, which is a quantity. We've got to multiply by the entire quantity And whatever I do to the left, I have to do to the right. So I'll multiply by the quantity b plus dx. I'll multiply by the quantity b plus dx. Now, as far as terminology goes, you can think of each of these quantities as a factor. So I've got one quantity multiplied by another quantity divided by another quantity, and in this case, very purposely, deliberately, we multiply by b plus dx because b plus dx divided by itself reduces to 1. And so on the left-hand side, I now have just a minus cx. On the right-hand side, I have this, and since we're solving for x, we need to distribute our negative a next. So minus ab minus a dx. Notice the entire negative a got distributed. Now I'm going to put a little star here. At this point, you should feel pretty confident in solving for x. Remember the process. We move anything with an x to one side, everything else to the other, factor out our x because we're solving for x, and divide. So let's go ahead and do that. You have options. I will add a dx to both sides. That's an a dx. And I'll subtract a. I'll subtract a. And that leaves us with positive a dx minus cx is equal to negative a minus a b. Factor out my x. X times the quantity ad minus c is equal to negative a minus a b. I'll divide by ad minus c, divide by that quantity, divide by the quantity ad minus c, and that reduces just to x, and we've got x is equal to this quantity. As you've seen many times before at this point, if I had moved these values up here in the opposite direction, then I would have had the opposite sign for every single one of these terms, and that would have looked like this. A plus a, that's an A, not a D, a plus a b divided by a d minus c. Next example, we're asked to solve for t, and you can see that t shows up twice in this equation. And so you may, I'd encourage you to pause and try this on your own first. You may have guessed that the first step would be to take this denominator and multiply both sides by it. Now I'm not going to write that out, but follow along. That would leave us with at minus b is equal to 3 times c minus b times the quantity 1 minus 2t. So again, I multiplied the left side by that entire quantity. I multiplied the right side by that entire quantity, and that put me here, because when I multiplied the left side by it, this reduced to 1. This piece reduced to 1. Okay, the next step is we would distribute our negative b, and so that would leave us with 3 times c minus b plus 2bt is equal to at minus b. Again, we're solving for t. We want t equals something in the end, and we still have some work to do. I'm going to change colors here for you. Next step is we will distribute our 3, and so we've got at minus b is equal to 3c minus 3bt plus 6bt. And I apologize, this should not have a t in it, so let me erase that t. And you may want to double check my error there. I distributed my 3 again, so let's go back just a second. Distributed my 3, that gave me 3c. should be my 3. I should have said negative 3b. And then lastly, distribute my 3, and that gives me my positive 6bt. Again, we're solving for t, so I'll subtract 6bt because that term has a t in it. That's 0. I'll add b, get that out of there because that does not have a t in it. And so on the left, we now have negative 6bt plus a t is equal to 3c minus 2b. And I got that minus 2b by combining like terms, minus 3b and plus 1b. We're almost there. We'll factor out a t. T times the quantity negative 6b plus a is equal to 3c minus 2b. And when I divide both sides by that quantity, I'm left with t is equal to 3c minus 2b over a minus 6b. Again, a minus 6b is the same as negative 6b plus a. The temptation is probably there to cross out your b's. You cannot, as we've talked about before, cross out your b's. Last but not least, I'm asked to solve for b. And I can see that b shows up once, twice, 3 times. Again, the process is eventually we need to move anything, any term with a b to one side and everything else to the other. But before we can do that, we have to expand. And by expand, in this case, I mean distribute. So there are 3 times that we'll have to distribute. In the first case, ab plus 2a. In the second case, plus cb minus 3c. And in the third case, db minus d. Now, planning ahead, I've got a b term, I've got another b term, and another b term. Those 3 need to be on the same side of the equal sign, and everything else on the other. So I'm going to go ahead and subtract db, and I'm going to rewrite. So on the left, I've got ab minus db plus cb. I'll subtract 2a, I'll add 3c, and now on the right side, of course that went away, I have negative d minus 2a plus 3c. We're solving for b. I'll factor out a b. b times the quantity a minus d plus c is equal to negative d minus 2a plus 3c. Last but not least, I'll divide. And I now have isolated b, which was the goal all along. Again, you may be wondering, can I get rid of these d's, for example, or can I get rid of these a's, for example, or can I get rid of these c's, for example? You cannot. If you had something like a, b over b, c, in this case we have all multiplication and division, you absolutely could reduce those b's. But up here, notice we're adding and subtracting, and again, we'll talk about that a bit more in class. You cannot reduce.